Decision Based Image Encryption Algorithm. Abstract. In most of the cryptological methods, the encrypted data or the cipher texts maintain same statistics of the plain texts, whereas matrix encryption method does not keep the statistics of individual cipher texts. However, it maintains the statistics of block of characters of size m, where m is the size of the key matrix. One of the important features of the cipher matrix in residue number system, RNS, is that it is highly difficult and time-consuming to obtain its inverse by standard inverse algorithms. Matrix in RNS does not have all the eigenvalues as defined in complex field. The eigenfactors of a matrix are defined as the irreducible factors of the characteristic equation, eigenfunction. All the above properties are valid for cipher matrix in Galois Field. The public key is generated by using two types of matrices. One of these matrices is a self-invertible matrix or an orthonormal matrix in Galois Field, whereas the other matrix is a diagonally dominant matrix. Matrix inversion is very difficult and time-consuming when size of matrix and modulo number are large. The computational overhead in generalized Hill cipher can be reduced substantially by using self-invertible matrices. Self-invertible matrices uses less space compared to invertible matrices. In order to overcome this problem, P, modulo, is made very large so that there would be at least Pn/2 possible matrices, making it extremely difficult for the intruder to find the key matrix. In this paper, a decision-based image encryption, DBE, algorithm is proposed that will generate self-invertible matrix for decryption based on DBE algorithm. Keywords: decision-based image encryption, encryption, binary coded decimal, BCD, encryption, image, DBE. Introduction. In recent years, the world lives in the age of communications revolution, which necessitates multimedia transmission in a secure manner. Encryption is important in transferring images through the communication networks to protect them against reading, alteration of its capacity, adding false information, or concealing part of its contents. 1. Owing to the frequent flow of digital images across the world over the transmission media, it has become essential to secure them from leakages or threatening or brute force attacks. Our proposed encryption scheme is subjected to encrypting on the basis of modified BCD, binary coded decimal, form as BCD representation of number require more than 8 bits to represent all 255 pixel magnitudes. The proposed algorithm uses the following pattern of representing each pixel magnitude. Example: A equals 04 is represented as 00000100 in modified BCD form, which is same as binary representation. All the pixel magnitude from 0 to 7 follows the same binary representation, so example with A equals 07 follows. Third example is A equals 72. 72 is represented in modified BCD form as 01110010, and 72 in binary form is written as 1001000. Same pattern follows for all pixel magnitudes between the range 10 to 159. The pixel magnitudes from the range 160 to 255 follows a different pattern as shown in example with value of as 160, 217, 255. 160 in binary is represented as 1010000, 160 in BCD form is written as 100000000, and in modified BCD 160 is represented as 00001000, so as 217 and 255. 2. Related work. Image encryption algorithms are used to safely store images on cloud, and only authorized users can decrypt the image. Chaos-based image encryption has applications in many areas, such as online communications, medical imaging, military communication, etc. Image data contains special properties such as high frequency and high pixel-to-pixel relationships. 23. Proposed a new image encryption algorithm, where the gray values of image pixels are mixed and changed to confuse the relationship between the encoded image and the normal image. First, Arnold cat map is used for switching image pixel positions. Authors had explained with experimental results that the key space is large to resist brute force attack, and that the distribution of gray values for the encoded image has random behavior. 58 proposed an image encryption scheme where the 80-bit secret key and 2 chaotic logistics maps are used. With the initial conditions of the logistics maps are derived using the key which is external. Authors have proposed encryption process that includes 8 different types of processes to encrypt an image, and one of them is used in a given pixel on the logistics map output. 93 introduced image encryption with some propagation effect in the substitution phase by addition and simple serialization. The time taken is longer to process in a single round the encryption. 90 authors proposed cryptographic image-based algorithm with varying control parameters. The control parameters included in flipping phase and the key current used in the propagation stage are generated from 2 chaos maps related to the normal image. Authors showed the result of proposed algorithm can resist all known attacks against diffusion propagation structures effectively. 37 proposed an encryption system that included 2 parts, mixing chaotic pixels and W7. An anarchic map is used to create a two-way flipping matrix to build a shunt. The flipping matrix has a desirable property and reflects its inverse. Shuffling expands the propagation property and reduces the vertical, horizontal, and diagonal link between adjacent pixels. The number of times each gray level occurs in the image is not changed after the pixel is mixed. Even the image mixing chart is the same as the normal image chart. 2. The proposed image encryption algorithm. This algorithm is based on the principle of Rubik's Cube to create image pixels. To confuse the relationship between the original images and the encrypted images, the XOR operator is applied to individual rows and columns of the image using a key. The key itself is turned and applied to rows and columns even from the image. 38 proposed a multipurpose PKI encryption system. The authors provide a solution to meet the increasing requirements for safe image transfer across networks. Supports multilevel encryption based on encryption of various image sizes. 88 worked with an image encryption algorithm based on double helix surveys and chaotic maps. Their main contribution was to perform double helical scan that can effectively mix pixels from the image block. Content-based keys are genes. 4 results and analysis. Simulation on the DBE encryption algorithm is done on Akio, Big Buck Bunny, Bridge, Close, Bridge, Far, Bus, Carphone, Claire, Coast Guard, Container, Elephant Stream, Waterfall, template test video files and around 100 video clips from YouTube. Figure 1 shows the stages of ciphering video frame. The results show that perceptibility of ciphered video is decreased as the object of interest gets encrypted. Figure 1, stages of video frame encryption: A. Original image, B. Region of interest pixels encrypted using DBE algorithm, and C. Decrypted video frame. Analysis of results. In this section, the proposed algorithm is subjected to various security analysis and analysis to ensure its accuracy. Precession time table 2 contains the time taken by some of the most commonly used cryptographic algorithms for single pixel, EAS, XOR. RSA algorithms are coded in MATLAB 16b and Blowfish algorithm in C++. DBE takes less encryption time than other algorithm with less complexity. Table 1 shows the proposed DBE encryption algorithm take least encryption and decryption time as compared to other state-of-art techniques. Visual degradation. The maximum signal-to-noise ratio, PSNR, is used to measure the level of optical distortion in the encoded video. With mean square error, MSE, image compression quality can be compared. The MSE describes the separation of the square between the extruded image and the original image, while the PSNR describes a measure of error resolution. A lower MSE value means less error is committed. However, a lower cost of PSNR means higher optical degradation of image encryption. PSNR and MSE were calculated as described in Equation 1 and Equation 2 respectively. 1. Where M is maximum fluctuation in input image. 2. The average PSNR and MSE values for the specific encodec video frame are shown in Table 3. The lower PSNR values and higher MSE values give a difference between the encoded video and the normal pattern. Table 2, Comparison of original frame to ciphered frame. Comparison of original frame to result. Domain VIFP relies on two data variables, the statistics between the first and last stage of the detected channel when no separation exists, and the second variable is the data transformed between the input distortion block and the output of the detected system blocks. For the reference image or the left voice, the signal must pass through the visible canal before entering the brain, where the brain data comes from. As is the case with noisy images, the source signal passes through another biased channel before entering a detected channel. Combining the two variables mentioned above, the accuracy is obtained. Chosen known plaintext attacks. Figure 2 histogram analysis shows the effect of selected /known attacks. Normal video frame A, and similar encoding frame B. Because the histogram of part A, and part B, of the objects of interest varies, the proposed technique as opposed to attacks selected/detected by unknown ideas is given limited resources and amount of video over time. Figure 2, histogram, A, original video frame, B, encrypted video frame. Decryption efficiency. The total difference between the original pixel frames and the recovered frames is approximately 99.8% the same as the original. These results indicate that the decoding process captures normal video with the corresponding 99.8% encryption algorithm generating an error of 0.2%. Conclusion. The encrypt ROI through the proposed decision-based encryption and decryption algorithm. The proposed methodology reduces the encryption and decryption time as only the selected regions need to be encrypted. Proposed DBE algorithm is fast, robust and secure for any type of data.